about service mount, so take it away, Steve, you got next hour.
All right. I guess the first thing I want to tell you is if you've been afraid of surface mount, you can do it. You can do it. Now, there's certain things that you're going to see are not in the realm of the average hobbyist, but most of it is. Now, what I've got here, I'm going to pass them around so you can see them. These are junk surface mount boards. They came out of Sony cameras at one point in time. If anybody wants to take one of these home and play with it, you know, it's a perfect tool for that. So I'll just pass these around while we're going through our material. And we're going to start off by obviously noting that they're pretty small. Some of them are not much larger than a grain of pepper. These are the ones that we normally encounter in ham gear. So we have a variety of different components here. We have a flat tack, we have a J-lead, electrolytics. These are very common to go defective in gear. Paul had some that needed replacing in a microphone a while back. And then, of course, the small resistors and capacitors.
Steve, on the lower right there, I think there's one missing.
That's the dot in the eye there.
Yeah.
Oh,
The electrolytics you were pointing out, I've got a Kenwood 850 ran into those. And the story is those were counterfeit electrolytics that ended up leaking.
Well,
Because they didn't get the chemistry right when they counterfeited the electrolytics.
Panasonic made a lot of electrolytics some years back that went bad, and one of the telltale signs is if you smell them, it smells like fish oil. So if you've got a cap that stinks a little bit, that cap is bad, guarantee you. And I don't know about the counterfeit ones, but I know that a few years back, we were replacing thousands and thousands of them due to them going bad and leaking.
So were they using fish oil or were they using the correct oil?
Yeah.
olive oil, is that?
Yeah, they actually leaked the lytic compound, and that's what stunk. Now they're not always in cylinders. Here's an example of a small rectangular electrolytic.
The electrolytic, titanium or whatever.
They can be either.
Okay.
They can be either. These are the dreaded and feared flat packs. There is a method of getting these off the board and back on the board without wrecking things. You can use a razor blade. There are a number of different ways to go about it. This is showing. This is just giving you a little different perspective on it. This is another common type of chip. Notice that the leg is kind of in the shape of a J. And these are actually pretty easy to take off and solder back on. Notice that you have little solder fillets here. And the nice thing about these chips is the spacing on them is a little wider.
They do that for thermal.
Can be thermal, yeah.
You didn't mention the technique for removing the,
I'll get to that.
oh, okay.
I'll get to that. Just kind of showing a few different styles. Now, these are what they call ball grid arrays, and BGAs have all the connections underneath them. It is possible to take them off. It requires, I'll show you poor man's way, and then there's the rich man's way, you know, the way it's supposed to be done.
Floorings and you can't do it with a skillet.
Yeah.
Reball them and everything too.
You have to reball them. So, and here's your PCB, an example of a PCB board. There's 352 contacts on this particular one. And you might think, well, how can you ever line them up? It's kind of interesting, when you install them, if you get them centered just about right and you apply the heat, they'll kind of self-align. Now, if you want to check your work, now that requires an X-ray machine and, you know, all of that good stuff, but at any rate, I don't recommend getting involved with this at all, but it is part of the surface mount world, so threw it up there. Now, passive rectangular components come in different sizes, and these two that I highlighted in red are the most common sizes that you're going to come across. Now, this becomes important if you're going to design a board that's going to have some surface mount stuff on it, because you have to stipulate the exact size of the component to get the pads correctly, you know, set on your board.
1206s are actually oftentimes
That's
bigger.
what I love.
Yeah, they're
For
almost
kits.
bigger than having a resistor with a vertical resistor. So they're big.
When I have to make kits for people to put together, I can put 12 or 6s on and people love it.
Yeah.
And so I try to do that unless I have to, if everybody cares for space.
402s are pretty tiny though.
Cool ones and worse.
Steve, this is a measurement of the package, not the pin space.
Correct. This is the package, right? And you can see similar for ceramic capacitors. Here's a little chart for tantalum capacitors. And then there's the coding system. Now, there's good news and bad news. If there's a code on the device, it's pretty easy to decipher. A lot of times there's nothing printed on the device, and so you're gonna have to check it out. But anyway, so here's a
That because you only put the code on one side of the device?
So there isn't room.
No, it's either there's not room, or a lot of times what I found is that they'll print a value for higher value resistors, but for lower value resistors, 150 and 1K, so anything basically below 1K, they don't even bother printing it.
Yeah, that's becoming very common. But here's an example. The first two are your values, and the second is the multiplier. Now, if the resistance is less than 10 ohms, they'll use an R. So, for example, they're giving here 4R7 would be 4.7 ohms. And then if you can fit it in, there's a 4-figure code, and the first three are your values, so this would be 470 and then 10 to the second. So that's your value. And then finally, there is an EIA code, which is very confusing if you don't know what it means. And this is where the last letter, character is a letter. And you have to go on this, on your chart, and that will give you the multiplier for it. Now, the first two characters refer to the significant figures, but you have to use the chart. So they give the example here of 68, and if you go look on the chart to 68, and then you're going to see that means 499, and then you multiply it out. So there's 3 code, 4 code, and then this EIA code. And once you know what it is, it's simple to interpret, but you have to know, okay, well, this is what it is. capacitor codes, capacitors are worse than resistors for putting values on there. But again, it's the same deal. The first two are your value, and the third is your multiplier. Electrolytics have a letter code, and that corresponds to the voltage rating, which is kind of important to know. And then that brings us to tools. And so everybody wonders, well, how much do I have to spend to be able to work on surface mount stuff? So the one thing, and this is just a personal opinion, but the one thing that I think is the most important are two, and I say two because you have to use them kind of like chopsticks a lot of times, two quality temperature controlled irons. You don't, if you're going to go out and buy an iron, don't buy, some cheap iron. Get a good Weller or a Hayco, or, there's all sorts of them out there, but get a good quality iron. And you're looking at probably $120 to $150 per iron. But then remember, those irons are going to last you probably a lifetime with a little bit of maintenance. You also need some hand tools. And top of the list is a good magnifying lamp. So if you don't have a good magnifying lamp, you want to get one. But then also you'll find a good loupe. And I've got these, this particular clip-on, which you might find interesting, very useful, or you can just get a cheap one. But the problem with the handheld ones is, well, there goes a hand, right? A lot of times you want both your hands free to work. You want to use premium solder. Don't get the cheap stuff. It doesn't have to be silver solder, but spend the money to get like a good Kester number 44, something like that. And, again, it's a few more bucks, but a roll of that will last you a long, long time. Get premium flux. Now, the flux comes in a variety of ways to, I kind of like, for just general purpose, the liquid flux. And it's got a brush applicator on it. But the stuff that comes in a syringe, that's real good as well. And then they make flux pens. They're handy, but they kind of dry out fast. Now here's the thing to remember about the flux. The flux goes bad. And especially if you get the flux in the syringe, which will run you like $10 to $15 depending on where you get it. That stuff, you should keep it in the refrigerator. I don't, I never have. But technically, the shelf life of it is about a year. So kind of keep that in mind. But premium flux is important. Spare solder tips, brass wool. I never believed in this stuff, but I use the sponge on my iron, but this is also nice for kind of getting the tip a little clean. I don't know if this is, you can get replacement brass wool, after your sponge gets kind of gunky. And it really works well keeping the tip clean. You want dental picks of various sizes. You want some sharp side cutters. And you want a tweezer probe. And I have to attribute it to Alzheimer's because I had my tweezer probe out and I went to put it in the box this morning and I couldn't find it. But anyway, the one I have is, I think I spent like $10 from Janeco a couple couple of years ago.
That one of those ones with the hooks on it, or is it actually a?
Yeah, it's a little tweezer, yeah, it's like yeah, and it's got a couple banana, jacks on the other end, and you plug it into your DVM. Or, in the case of, trying to identify components, I use it with this LCR meter. This is just a cheap B&K. I've had it for years, and it's actually pretty accurate. Works very well for identifying components that you're unsure about.
Adafruit actually sells a little LCR meter built onto the back of a pair of tweezers.
They're very expensive though.
Well, I don't remember how
A
much
couple
they are.
$100 for some of those.
Well, they have one that's, I don't think it's more than 50.
Okay.
You just
I
clamp
looked at
onto
some of
either
them.
side of your lead and it tells you
They're wonderful
exactly what
too.
you've got.
They look really great.
Smart tweezers, I got one.
Yeah.
Yeah,
But they're about two something.
Yeah, that's how I've got them.
So this is what I've got, and
That's nice.
it's about $10, and
That's slick.
it works out.
Yep.
That, you know, if you use them every day for work, they probably wouldn't hold up, but for, you know, hobbyist use, it's fine. Now, another thing that is very useful is something called a pyro pen. And this is made by Weller, and what it uses, you know, butane lighter fluid, and you light it, and it blows out hot air. And this is useful, for example, if you have to take a flat pack off that's glued to the board, you have to loosen that glue, and this can be used to heat the flat pack. You can also, if you're brave enough, you can also use it to melt the solder on all of the pins, and then with your dental pick, you can pry it right up. These have different, this is the junior, and then they make one that's like twice the size, and then they have like soldering tips for it. Really handy if you have to go on a roof or out in the field, and you need a bunch of heat, but you don't want to run a cord out there.
fantastic for doing SL239s.
The big one for underneath the dash of cars is you're soldering up inside the dash of a car and you're standing on your head.
Yep. Here's what they call a tweezer iron, and Tenma sells this for about $30. Basically, it allows you to come on both sides of a surface mount device and apply heat simultaneously. I've never used this style. I have used this style, a professional set at work. And these are the cat's pajamas if you're doing, if you're doing this for money, you would want this. This is also expensive. Essentially, everything you can do with this, you can do with two good quality heat-controlled irons.
Do you know if Weller makes a replacement pencil for their bases with that type of tweezer? I don't know, but if
No.
they did, that'd be great.
Yeah, I don't think this is a Weller design. I think this is another, but there's, I know Weller makes those. The ones that I'm familiar with that I've used are made by Pace.
Yeah, Pace, Metcal, JVC, they all make the tweezers.
This is an example of a hot air device. Basically what you have is you have a control unit with a little pump in it, an air pump, and you're gonna blow focused hot air out these manifolds. And you fit those over your square chip or rectangular chip. You have to have the right size manifold for it. And it heats everything up, and when it's ready to come off the board, you just give a little tiny bit of pressure with your dental pick, pops right off. These are expensive, and if anybody needs, I've got not a Heiko, but a Hosan model with the common manifolds. So if you got some weird chip, I won't be able to help you, but if it's one of the more common sizes, and you need one taken off, let me know and I'll be glad to help you out.
But does that actually blow the hot air on the component, or does
It
that
will-
heat the tip
No,
with hot air?
no. This is hot air coming out four sides in this case.
Okay.
Now, not shown, but in the early days, when they first came out with these surface mount flat packs, you would get an iron, like I think this is an American Beauty, with the appropriate, that we call them kludges. Anyway, what you would do is you would get this up to temperature, you would melt solder all around it, you would jam it down on the chip, heat all the pins up simultaneously, and then with your dental pick you would lift it up. I still have all the common sizes for these, and these are, you know, they work very well, but they've fallen out of favor. Now, we're going to see that there's a lot of devices that have got 3 or 4 terminals on them, and you need to, in the removal process, you need to heat all of these terminals up simultaneously. Well, this is where having something like this comes into play. This actually, I'll pass it around, you can see that it has, you can screw on different size tips to, you know, various widths to heat the terminals up simultaneously. These are fairly inexpensive, but again, for most cases you can get by without going to this level. Now, whenever you're dealing with surface mount technology, you're going to be dealing with plated through holes. And if you have to unstop a plated through hole, if you don't have some kind of vacuum operated device, you're pretty well done for. And this is where solder sucker is really helpful. Here's an example of a weller. I have an old pace unit that works well. Again, if you run into a bind with a plated through hole, let me know, and maybe I can help you out with that. And then for those that really want to get into it, there's the venerable toaster oven, and frankly, I have never used a toaster oven myself, but I know folks that have,
I have.
and it works. And the idea is that, you know, you're gonna get all your stuff on the board, and you're going to put it in the oven, and the solder's gonna melt, and you're good to go.
What's really big on those is getting almost the cheapest oven you can get, and then you send off for a board and build a controller, and you can, because a lot of the components have a ramp up, hold, and ramp down, and the controller can be programmed for the devices you're working on it. Then you don't use anything in the oven, but you, with the little controller you can build, just do exactly what is spec'd out on the device.
Yeah, because the idea is you can't, you actually, if you're going to put a board in an oven, you have to preheat them properly, so there's a kind of as you mentioned, a ramp up, and then there's the actual temperature where the flow takes place, and then you can't, like, you know, just take them out in the cold. They have to cool down somewhat gradually. I've never done a personal project where I've needed this, but you know, there's a whole little science behind it.
built one for my last company, and if you have to do a lot of batch SMD, they're a godsend.
Oh, yeah. Yeah, so that's, yeah, even if you were gonna do a small run, that would be the way to do it. Now, let's say you buy that little ornament, surface mount tree ornament, and you're gonna have some parts to solder on here. Well, how do you do it? Well, it's basically clean, flux, and solder. So first off, make sure your board's clean. If there's anything that's not clean on it, you gotta clean it up. And then you put a little flux down, and in this case, we're gonna put this little resistor on here. We're gonna tin one pad. Now we're gonna position the device over, and we're gonna solder that pad in. And what we're looking for is a little fillet here. And then we go over to the other side and we solder that. And it's pretty easy. Now, it's also possible, if you're gonna do a bunch of these, you can put a little adhesive underneath there, plunk it down, and then you allow, whatever the time is for the adhesive to set. And then you don't have to worry about holding it in place while you're soldering it. So that's kinda nice.
Gel super glue work good for that.
You can use super glue, but it does stink a little bit when it gets hot. Now, this is what we're looking for. We're looking for that nice solder fillet, right? And this would be illustrating the, dab of glue. This is very common. They call it the drawbridge fault. And then this is also pretty common, where the damn thing just, has a mind of its own and stands up on its head. And anyway, so you can't work with these without having some oopses along the way. You may have, some issues where things don't look exactly like they should.
Too much solder.
That's where you need some good solder braid, a little flux. You can clean things up, and it all looks good. Here's an example of using a tweezer, and these are the cat's pajamas for both removal and installation, if you got one. So, I don't have one of these. Now, when you get to transistors and diode packages, a lot of times you're gonna have 3 and sometimes 4 connections. Well, how do you deal with these? Well, that's where you want, ideally, you have an iron that's got a wide enough tip on it to hit, for example, all 3 of these at once. But if I was gonna be doing this particular one, what I would do is I would put some flux over here, and then I would hit the tab, and I would lift the tab just a little bit up off the board, and these guys here would have to bend just a little bit, and then I would take my tweezers and my iron, and I'd run back and forth here, and it would come right off for you. And you, believe it or not, you can, if you're, a little delicate with it, you can take it off and test it, and you say, oh, that was good. You can solder it right back on the board.
Steve, excuse my ignorance, why do you flux something when you're taking it off?
Well, it helps the solder to flow.
Oh,
Okay, so that's the main reason. And then when you use solder, use flux when you solder in place, because the flux will kind of chemically clean. And with surface mount, you're not applying that much solder. So even though the solder that you have has flux in it, generally there's not enough solder that gets melted and its associated flux to get things properly cleaned and let things flow. So that's why you use a little extra of that, and then you just clean off the residue. Now, here's a poor man's way of taking off a flat pack. There's a company called Chip Quick, and basically what they do is they sell a low temperature solder. And you run solder over all of the pins, and you get them all melted at the same time. So it's the whole thing's molten, and you pop it off. You don't actually need to buy the Chip Quick. If you get that Kester 44, you can do the same thing with it. It's got a little higher temperature melting point, obviously. The bad thing about this is when the chip comes off, you tend to generate these little solder balls that go everywhere. And that requires a bunch of, inspection, because you don't want that shorting anything out. But this method does work. The Chip Quick product does work. I don't use Chip Quick because I've got the other tools, but yeah, if you want to buy a Chip Quick kit and give it a whirl, it will work for you.
That's the solder they use for the oven that was in QST couple of years ago. He uses quick chip solder and flux, because of the lower temperature.
The main thing about Chip Quick is the time, the transition between liquid and solid is held so long that even if you remove the heat, 30 seconds later you might still be able to pull the chip up, versus your 3763, that they shorten the time so much you almost never get a cold solder joint because you don't get any movement during that liquid transition.
So what about building? So you got a little design and you got a choice. Should I go surface mount or should I go through hole? And unfortunately, sometimes the only thing you can get is surface mount. So here's one way to do it. And it works. It works. Here's another example, right? With some perf board and just tacking onto the leads. It works. It's not pretty, but you're doing a prototype or whatever. Well, maybe that's not your bag. You want something a little more professional. Well, then you get these breakout boards, and they come in all different sizes and flavors, and so here's 2 styles here, and here's another 2 styles, and you can get basically whatever you need to accommodate the package you're having to deal with. They're not always the cheapest, but generally you're only buying 1 or 2. And then you can go the proto board route. And so here's an example of somebody that's got some surface mount chips on a proto board. And you can buy these proto boards with the pads spaced the way you need it. And then again, this isn't the prettiest construction, but it also does work just fine. And then finally, this is how most of those breakout boards come, and there's some variant of this, so you can marry them up to your design. Well, guys, for our November build-a-thon, I'll bring the hot air machine in, I'll bring the solder sucker in, I'll bring the high-power magnifier in, and if anybody wants to do a little repair or anything like that, feel free. or if anybody needs a little help with getting something, pulled out or put in, give me a call and do what I can to help you out.
You gonna bring your junk boards?
I'm sorry?
You gonna bring those junk boards?
I can bring some junk boards, yeah, I've got, but if anybody wants to take one of these boards with them, feel free to take them. I don't need to take them home. I got a box of them, so. Well, thanks, guys.
I think Radio Shack might carry the smart board, you know, that
Yeah, they do.
I think they might.
Some of them do. Like the
Some
one in Apple Valley does, but the one in Burnsville Mall doesn't.
Yeah, they've got loaded solder on them, you know, that you can just kind of run the tip of iron. Let's see.
I think Janeco's got some, and I know Mauser's got, but the ones on the Mauser side are hard to find.
Lumber Center sells some of those carrier boards in their section, little do-it-yourself section.
Thanks, Steve.
Yeah.
Thanks very much.